Hey there, and welcome. Today, we're going to take a pretty incredible journey. Straight up. We're going to climb from the very ground we're standing on to the edge of space itself, exploring this amazing multi-layered shield that makes all life on Earth possible, our atmosphere.
So, let's just start with a simple question. Have you ever wondered what's really up there? What's this invisible force field that's protecting us from things like burning meteors or just the intense, deadly cold of space? Well, the answer is all around us, and trust me, it's way more complex than you might think. So that force field is our atmosphere. The easiest way to think about it is like a thick, cozy blanket of gases wrapped all around our planet, held in place by gravity. But it's so much more than just air. It's a super dynamic, layered system that is absolutely essential for us to even exist.
And here's what's really fascinating. This blanket isn't just one single thing. Nope, it's actually made up of 5 totally distinct layers, and each one has its own unique job to do. So you ready? Let's start our climb and check them out one by one.
Okay, first up, we're starting right here on our home turf in the lower atmosphere. These first 2 layers, this is where we live. It's where basically all human activity, all our weather, and all life as we know it really happens.
Our journey starts at the very bottom, in the layer you are literally in right now, the troposphere. This is our home base, the layer we see and feel every single day.
It goes up about 15 kilometers, and it's got all the oxygen we need to breathe. It's also where all of our weather hangs out. Clouds, rain, snow, you name it. And if you've ever been on an airplane, you've been cruising right near the top of this very busy layer. Now, here's where things get a little weird. In the troposphere, as you go up, it gets colder. Makes sense, right? Like climbing a mountain. But then, as we cross into the next layer up, the stratosphere, something totally bizarre happens. The trend reverses. The higher you go, the warmer it gets. Any idea why that would happen?
Well, the secret is the famous ozone layer. The stratosphere, which goes all the way up to 50 kilometers, is home to this absolutely critical shield. What it does is absorb the sun's most harmful ultraviolet radiation. And that process of soaking up all that energy, well, that's what actually heats the layer up, creating that strange temperature shift. It's basically our planet's own natural sunscreen.
All right, let's buckle up and leave the familiar behind. We are now climbing into the upper atmosphere. This is a much colder, thinner, and way more extreme environment. It's our gateway to the cosmos.
Our next stop on the tour is the mesosphere. We're getting way up there now, leaving something like 99.9% of the atmosphere's mass way below us. And while it might seem pretty empty up here, this layer has a super important job.
And that job is protecting us from space rocks. This is the layer where most meteors slam into enough air particles to burn up from friction. So every time you see a shooting star streak across the night sky, you're actually watching the mesosphere doing its job as a planetary shield, right in real time.
But here's the irony. Despite all those fiery meteors, the mesosphere is the coldest place on Earth. Seriously, temperatures here can drop to minus 90 degrees Celsius. That's cold enough to instantly freeze any water vapor into these beautiful, shimmering clouds high up in the sky. Okay, we're climbing higher still, entering the gigantic thermosphere. And after that deep freeze in the mesosphere, the temperature here gets extreme, but in the exact opposite direction. Now get this, the air here is incredibly thin, but the few gas particles that do exist are soaking up so much high-energy radiation from the sun that their temperature just skyrockets. We're talking over 1,500 degrees Celsius. But you wouldn't actually feel hot because the particles are just too far apart to transfer that heat to you. How wild is that? This is also the layer where those beautiful auroras dance, and it's where the International Space Station orbits our planet. We've almost made it. We've reached the very top of our atmosphere. This is the final frontier, that really thin veil where our planet's influence just kind of fades away into the vastness of space. And our final stop on this incredible climb, right at the edge of everything, is the exosphere. Think of this as the atmosphere's last gasp. The air is so thin here that single atoms and molecules can actually escape Earth's gravity and just drift off into space. This is where a lot of our weather and communication satellites hang out, in this huge transitional zone. And unlike all the other layers, there's no clear end to the exosphere. It doesn't just stop. It just fades, particle by particle, into the vacuum of space. It's this really gentle merger of our world with the rest of the cosmos. So, we did it! We made it all the way to the top. Now, let's zoom back out and take a look at the big picture, so we can really appreciate why this whole system of layers is just so important. This chart really lays it all out for us, doesn't it? From the weather and all of us down here in the troposphere, to the ozone layer in the stratosphere, that meteor shield in the mesosphere, the auroras up in the thermosphere, and that final fade into space in the exosphere, each layer has its own job and its own weird temperature profile.
So what's the big takeaway here? It's that these aren't just separate layers. They're one big, interconnected system. A system that gives us air to breathe, shields us from space junk, keeps the temperature livable, and drives the water cycle. Without this perfectly balanced atmospheric shield, life as we know it well, it couldn't exist. It's as simple as that.
Which leaves us with one last, pretty mind-blowing thought. This complex, life-giving atmosphere makes our planet a really precious and rare thing in the universe. It makes you wonder, doesn't it? What amazing, intricate balance of gravity, chemistry, and just pure luck would it take for another world out there to get a protective blanket just like ours?